Hello everybody, today we will continue chapter 11, lesson 3, page 397. In this chapter we will discuss ions, ionic bond and metallic bond. What's an ion? An ion is an atom that no longer electrically neutral because it has lost or gained valence electrons. Because electrons have a negative charge, losing or gaining an electron changes the overall charge of an atom. So, atoms that lose valence electrons become ions with a positive charge. Metal atoms, such as sodium, become more stable when they lose valence electrons and form a chemical bond with a non-metal. For example, let's look here. We have sodium atoms have a tendency to lose a valence electron, while chlorine atoms have a tendency to gain a valence electron. Why? If you look here, you know that sodium is a metal, and at its highest level here, it has only one electron, and sodium has a tendency to lose this valence electron. The electron found at the highest level, we call it valence electron. So, when a sodium atom loses its valence electron, it becomes a positive charge, a positive ion with a charge of +1 because it loses only one electron. If we look down now, we have a chlorine atom. This chlorine atom has 7 electrons on its highest level. This is the highest level here. You can see. Okay, this is the highest level. So, if you count the number of electrons here, you can see that they are 7 electrons. Now, chlorine atom will gain one more electron to become stable because, and for an atom to be stable, it must have 8 valence electrons on its highest level. So, chlorine will gain one more electron and it becomes a negative ion with a charge of -1 because it gains one electron. So, an atom or atoms are electrically neutral. Why they are electrically neutral? Because they have the same number of protons and electrons. But once an atom gains or loses electrons, it becomes a charged ion. So, when forming a compound, the non-metal atoms gain the electrons lost by the metal atoms. The attraction between the positively and negatively charged ions in an ionic compound is an ionic bond. Now, let's look here. In this example, we have 2 atoms. We have Na and Cl. So this is Na sodium and Cl chlorine. Na has only one valence electron on its highest level. You can see it has only one valence electron on its highest level, while chlorine has 7 valence electrons on its highest level. Now, for Na to be stable, because it's a metal, it will lose its valence electron, and you can see here. Now, it has only 2 levels, and on its highest level, it has only 8 electrons. While if you look at Cl now, it has 8 electrons on its highest level. Before, there were only 7 electrons at the highest level, and after gaining 1 electron from sodium. Now it has 8 electrons on its highest level. So now both Na and Cl has, or they have, 8 valence electrons on their highest level. So they are stable and they form an ionic compound called NaCl. So individual ions in an ionic compound are strongly attracted to each other. Covalent compounds are made up of many molecules. When non-metal ions bond to metal ions in an ionic compound, there is a large collection of positively charged ions and no molecules. So they are totally different from covalent compounds because, as we said before, that covalent compounds are made up only of non-metals, while ionic compounds are made up of metals and non-metals. Now let's have a look at metallic bond. What's a metallic bond? Is a bond formed when many metal atoms share their pooled valence electrons. Valence electrons in metals are not bonded to one atom. Instead, a sea of electrons surrounds the positive ion. How guys? Let's look at this picture. You can see here that this is a sea of electrons. Okay, they are free to move among the aluminum ions. Okay, and as we said before, okay, valence electrons in metals are not bonded to one atom, and a metallic bond formed when many metal atoms share their pooled valence electrons. So they share the pool of their valence electrons. Like can you see in here? Okay, all of these together. Okay, so these atoms or these electrons here shared among all the atoms. Okay, now metals are good conductors of thermal energy and electricity. These are properties of metals we studied before. Metals are shiny because the valence electrons at the surface of metal interact with light. So why metals they are shiny? Because these valence electrons at the surface they interact with light. Okay, this property is called luster, if you remember from previous lessons. Okay, now let's have a look at this table. It summarizes what's the covalent, ionic bond, and metallic bond. Also here we have the properties in each case. So first of all, the covalent bond, like in a water molecule H2O, as we said before, that non-metal atoms react with, or they are bonded with other non-metal atoms. Properties of these covalent compounds, they are gas, liquid, or solid, low melting and boiling points, often not able to dissolve in water. They are poor conductors of thermal energy and electricity. Of course, they are non-metal and they have a dull surface or dull appearance because they are not shiny, they are not metals to have valence electrons that interact with light. Ionic bonds. In ionic bonds, we have non-metal ions bonded to metal ions. Properties of ionic compound. They are solid crystals. They have high melting and boiling point, dissolves in water. Solids are poor conductors of thermal energy and electricity. Ionic compounds in water solution conducts electricity. For example, if you put salt in water and you try to conduct electricity through water, then it works because of the salt dissolved in water, and salt is an ionic compound. Now, metallic compound, like in aluminium, they are just metal ions with metal ions, the same metal. Their properties, they are solid at room temperature. They have high melting point and boiling points. Do not dissolve in water. Good conductors of thermal energy and electricity. They have a shiny surface. They can be hammered into sheets or pulled into wires. Here you must remember malleability and ductility. Okay, let's have a look here. Now all of us know what's an ionic compound. But before studying the formation of this compound, how to form an ionic compound, first of all, we must remember together that we have elements in group 1 and 2. These elements are metals, and as we said before, that metals lose their valence electrons. Elements in group 1, they have only one valence electron, so they will lose this electron and their charge will become +1. While in group 2, they have two valence electrons, they will lose these electrons, and elements in this group will have a charge of +2. Also in group 13, they will have a charge of +3 because they are metals, so they will lose their valence electrons. While atoms in group 15, they have 5 valence electrons, and atoms in this group, the non-metal ones, they will gain electrons to become stable. So they have 5 valence electrons, they still need 3 more electrons to become stable. That's why their charge is -3. Group 16, or atom 16, they have 6 valence electrons and they still need 2 to become 8 and become stable. So that's why they will gain 2 valence electrons and their charge will be -2. While atoms in group 17, they have 7 valence electrons and they still need 1 more electron to become stable. So they will gain 1 more electron and their charge is -1. Of course, atoms of group 18, they are not reactive because noble gases already have 8 valence electrons on their highest shell, except helium it has 2, but it's still stable. Okay. So let's keep this in mind, guys. Now, to understand how an ionic bond is formed, we will take 3 examples. In these examples, example 1, we have NaCl, and example 2, BeO, example 3, Al2S3. So now, in the coming part, you will see how the ionic bond is being formed between these atoms in each example.